The rule you are referring to is indeed obsolete in the 2005 National Electrical Code. It was officially removed in Article 100 of the 2005 NEC. This means that if you're working with the 2005 NEC or any subsequent versions, you won't find its specific rule. Understanding the changes in each edition of the National Electrical Code is crucial for electrical professionals. The NEC undergoes revisions every 3 years, with each new edition incorporating updates, modifications, and deletions of existing rules. This continuous improvement process ensures the code remains relevant and reflects advancements in electrical technology and safety practices. To fully grasp the significance of this removal, it's helpful to understand what Article 100 covers. Article 100 provides definitions for terms used throughout the National Electrical Code. Definitions are the foundation upon which the entire code is built. When a rule is removed from the NEC, it could be due to various reasons. Firstly, the rule might have become redundant because of other changes in the code. Secondly, advancements in technology could have rendered the rule obsolete. Thirdly, practical experience in the field might have revealed that the rule was unnecessary or created unintended consequences. Finally, the code-making panel responsible for updating the NEC might have determined that the rule no longer contributed to electrical safety. When a rule is removed, it's essential to understand the implications. It doesn't necessarily mean that the practice the rule addresses is now acceptable. It could mean that the subject is now covered under a different article or section, or that the underlying concern is addressed through other safety standards. For example, suppose a rule dictated a specific wiring method for a particular type of equipment. If that rule is removed, it might be because the equipment is now designed differently, or a more general rule now covers the installation requirements. Let's consider how the NEC is organized. The NEC is divided into chapters, articles, and sections. Chapters represent broad categories, such as wiring and protection or equipment for general use. Articles delve into specific subjects within each chapter, such as grounding and bonding or wiring methods. Sections provide the detailed requirements for specific installations or equipment. To effectively navigate the NEC, use the index. The index is located at the back of the code book and provides an alphabetical listing of subjects covered in the code. When you're looking for information on a specific topic, start by consulting the index. The index will direct you to the relevant articles and sections. It is important to pay attention to the scope of each article. The scope defines the specific area that the article covers. This helps to ensure that you are applying the correct requirements to your installation. Understanding the definitions provided in Article 100 is critical for interpreting the NEC accurately. Definitions establish the meaning of terms used throughout the code. When you encounter a term you are unfamiliar with, refer to Article 100 for clarification. Another tool is to use the tables and figures within the NEC. The NEC contains numerous tables and figures that provide information on conductor ampacity, conduit fill, and other important parameters. These tables and figures are essential for designing and installing electrical systems safely. Become familiar with the symbols and abbreviations used in the NEC. The NEC uses a variety of symbols and abbreviations to represent electrical components and concepts. Understanding these symbols and abbreviations will help you interpret the code more efficiently. Also, attend NEC training courses and seminars. Many organizations offer training courses and seminars on the NEC. These courses can help you stay up to date on the latest changes to the code and improve your understanding of electrical safety practices. When interpreting the NEC, it's essential to consider the intent of the code. The NEC is intended to provide practical safeguards for persons and property from hazards arising from the use of electricity. This means that you should always apply the code in a way that promotes safety and protects against electrical hazards. The NEC is not intended to be a design manual. While the NEC provides requirements for the installation of electrical systems, it does not provide detailed design guidance. Electrical engineers are responsible for designing electrical systems that meet the requirements of the NEC and other applicable standards. The NEC is updated every 3 years. This means that it's important to stay up to date on the latest changes to the code. Subscribe to industry publications and attend training courses to stay informed. The NEC is adopted by many jurisdictions. This means that the NEC is the law in those jurisdictions. Electrical contractors and installers must comply with the NEC when performing electrical work in these jurisdictions. To find out if the NEC is adopted in your area, contact your local building department. The NEC is a complex document, but it's essential for electrical safety. By understanding the organization, content, and interpretation of the NEC, you can help ensure that electrical systems are installed safely and in compliance with applicable standards. Furthermore, there are several resources available to help you understand and apply the NEC. One valuable resource is the National Fire Protection Association, or NFPA, which publishes the NEC. The NFPA offers a variety of training materials, including handbooks, workbooks, and online courses. These materials can help you learn the code and stay up to date on the latest changes. Another resource is the International Association of Electrical Inspectors, or IE. The IE is a professional organization for electrical inspectors. The IE offers training courses, certifications, and other resources for electrical inspectors and contractors. Many electrical equipment manufacturers also provide resources on the NEC. These resources may include product catalogs, technical manuals, and online tools. These resources can help you select and install electrical equipment in compliance with the NEC. Consulting with a qualified electrical engineer or inspector is always recommended if you have questions about the NEC. Electrical engineers and inspectors have the knowledge and experience to help you interpret the code correctly and ensure that your electrical installations are safe. Grounding and bonding are critical concepts covered extensively in the NEC, particularly in Article 250. Grounding refers to connecting electrical circuits and equipment to the earth, providing a path for fault current to flow back to the source. This helps to trip circuit breakers or fuses, interrupting the flow of electricity and preventing electrical shock hazards. Bonding involves connecting metallic parts of an electrical system together, creating a low impedance path for fault current. This helps to equalize the voltage between different parts of the system, reducing the risk of electric shock. Overcurrent protection is another essential topic covered in the NEC, mainly in Article 240. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits and equipment from excessive current flow. These devices trip or blow when the current exceeds a certain level, interrupting the flow of electricity and preventing damage to the system. The NEC specifies the types and sizes of overcurrent protection devices that are required for different applications. Wiring methods are covered in Chapter 3 of the NEC, which details the different types of wiring methods that are permitted for various applications. Wiring methods include conduit, cable, and wire. The NEC specifies the types of wiring methods that are allowed in different locations and under different conditions. It also specifies the installation requirements for each wiring method. Equipment for general use is addressed in Chapter 4 of the NEC, which covers the installation requirements for various types of electrical equipment, such as receptacles, switches, and lighting fixtures. The NEC specifies the requirements for grounding, bonding, and overcurrent protection for different types of equipment. Special occupancies are covered in Chapter 5 of the NEC, which addresses the unique electrical requirements for different types of occupancies, such as hazardous locations, healthcare facilities, and swimming pools. The NEC specifies the special wiring methods, grounding, and bonding requirements that are necessary to ensure electrical safety in these occupancies. Special equipment is covered in Chapter 6 of the NEC, which addresses the electrical requirements for different types of special equipment, such as elevators, escalators, and electric signs. The NEC specifies the special wiring methods, grounding, and bonding requirements that are necessary to ensure electrical safety when using this equipment. Communications systems are covered in Chapter 8 of the NEC, which addresses the electrical requirements for communication systems such as telephone, cable television, and data networks. The NEC specifies the wiring methods, grounding, and bonding requirements that are necessary to ensure electrical safety for these systems. The annexes in the NEC provide supplemental information that is not part of the enforceable requirements of the code. The annexes include examples, explanations, and other information that can help you understand the code. It is important to note that the annexes are not mandatory, but they can be helpful in interpreting the code. Understanding the purpose and content of each chapter in the NEC is essential for navigating the code effectively. Each chapter covers a specific area of electrical safety, and it is important to be familiar with the requirements in each chapter. By understanding the organization of the NEC, you can quickly find the information you need and ensure that your electrical installations are safe and compliant. Remember to always consult the most recent edition of the NEC and any applicable local amendments when designing and installing electrical systems. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. When seeking to clarify specific changes in the NEC from one edition to the next, several strategies prove helpful. Firstly, review the preface and introduction of the new edition. These sections often highlight significant changes and revisions made since the previous edition. Secondly, look for change markers within the code itself. Vertical lines in the margins typically indicate sections where changes have been made. Thirdly, consult the analysis of changes document, if available. These documents provide a detailed explanation of the revisions in each new edition of the NEC. They are typically published by organizations like the NFPA or IE. Fourthly, attend code update seminars and workshops. Many organizations offer training courses specifically focused on the latest changes to the NEC. These courses can provide valuable insights and practical guidance on implementing the new requirements. Fifthly, compare the relevant sections of the previous and current editions side by side. This allows you to identify specific changes in wording, requirements, or tables. Sixthly, review the meeting minutes of the code-making panels. The NEC is developed through a consensus-based process involving various stakeholders. The meeting minutes of the code-making panels provide valuable insights into the reasoning behind specific changes. Seventhly, consult with experienced electrical professionals, such as engineers, inspectors, and contractors. These individuals can provide practical advice and guidance on interpreting and applying the new requirements. Eighthly, utilize online resources and forums. Numerous websites and online forums are dedicated to discussing the NEC and electrical safety. These resources can be a valuable source of information and support. Ninthly, consider the impact of the changes on existing installations. When a new edition of the NEC is adopted, it is important to determine whether the changes apply to existing installations or only to new construction. Tenthly, document your understanding of the changes and how they apply to your work. This will help you ensure consistent application of the code and provide a record of your compliance efforts. It's worth noting that the removal of a rule from the NEC does not necessarily mean that the underlying safety concern is no longer valid. It could simply mean that the concern is now addressed in a different way or that the rule was deemed to be ineffective or unnecessary. Always consider the overall context of the NEC and the specific requirements for your installation when interpreting the code. Furthermore, remember that the NEC is a minimum standard. It is always permissible to exceed the requirements of the NEC in order to enhance electrical safety. The NEC is not intended to be a design guide, but rather a set of minimum requirements for electrical installations. Electrical engineers are responsible for designing electrical systems that meet the requirements of the NEC and other applicable standards. The NEC is a living document that is constantly evolving to reflect changes in technology and industry practices. It is important to stay up to date on the latest changes to the code in order to ensure that your electrical installations are safe and compliant. In addition to the resources mentioned above, there are also several software tools available that can help you navigate and interpret the NEC. These tools may include searchable databases of the code, interactive diagrams, and calculators. These tools can save you time and effort when working with the NEC. When using software tools, it is important to verify the accuracy of the information. The NEC is a complex document, and it is possible for errors to occur in software implementations. Always double-check the results of any calculations or searches to ensure that they are correct. In addition to understanding the technical requirements of the NEC, it is also important to understand the legal and regulatory framework that governs electrical installations. Electrical work is typically regulated by state and local governments. These regulations may include licensing requirements for electrical contractors and inspectors, as well as permitting requirements for electrical installations. It is important to comply with all applicable regulations when performing electrical work. Failure to do so can result in fines, penalties, and even criminal charges. Furthermore, it is also important to be aware of any applicable industry standards or best practices. These standards may provide additional guidance on how to perform electrical work safely and effectively. Examples of industry standards include those published by the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI. Complying with industry standards can help you demonstrate that you have taken reasonable steps to ensure the safety of your electrical installations. In addition to the above, it is crucial to maintain accurate records of all electrical work performed. These records should include details such as the date of the work, the location of the work, the materials used, and the results of any inspections or tests. Maintaining accurate records can help you demonstrate compliance with the NEC and other applicable regulations. It can also be helpful in troubleshooting problems or performing maintenance in the future. When it comes to specific examples of changes from one NEC edition to another, consider the requirements for arc fault circuit interrupters, or FSIs. Over time, the NEC has expanded the areas where FSIs are required in residential wiring. FSIs are designed to protect against fires caused by arcing faults, which can occur when damaged or deteriorated wiring creates a spark. Another example is the evolution of ground fault circuit interrupter, or GFCI, requirements. GFCIs are designed to protect against electric shock by detecting ground faults and interrupting the circuit. The NEC has expanded the areas where GFCIs are required, particularly in wet or damp locations. Changes have also been made to the requirements for surge protection devices, or SPDs. SPD are designed to protect electronic equipment from voltage surges caused by lightning or other events. The NEC has introduced new requirements for SPD in recent editions. These examples illustrate the ongoing evolution of the NEC and the importance of staying up to date on the latest changes. The NEC is a dynamic document that is constantly being revised to reflect new technologies, industry practices, and safety concerns.